Hey there, this is Mrs. Thompson, and today we're going to go over naming molecules. First, you need to remember the difference between an ionic compound and a covalent compound. Ionic compounds are made up of a metal and a nonmetal. These are held together by an ionic bond, which is why we call them ionic compounds. Ionic bonds involve the transferring of electrons. This one is super important that you know. The metal is giving up its electrons, it's transferring its electrons to the nonmetal. We call the compound that forms from this a formula unit. Whereas a molecular compound is formed between two nonmetals or more than two nonmetals, but nonmetal, nonmetal. These are held together by a covalent bond, and they involve the sharing of electrons. Instead of transferring, they just share. So both electrons involved, or however many electrons they're sharing, are part of completing the octet for both of the atoms involved. We call a covalent compound or molecular compound a molecule. When I'm looking at a set of compounds and I want to figure out whether or not it's ionic or covalent, what I need to do is look at the elements involved. And so I'll start by figuring out which one of these are covalent. Remember that covalent compounds involve at least two or more non-metals. So I'm looking for formulas with just non-metals. Remember that the non-metals are over here on this side of the periodic table. They're in blue, and you also have hydrogen right here. Okay, so if I'm looking at this first one, it starts with Ca, which is calcium. Calcium is right here, so it is not a non-metal to start with. It is a metal. So since that is a metal, this is not a covalent compound. Okay, let's look at the next one. We have S, which is sulfur, and O, which is oxygen. We have two nonmetals. So as soon as we see nothing but nonmetals, we're going to circle that one to say that this is a covalent compound. All right, this one, Al and P. So we have aluminum and phosphorus. Aluminum's over here in yellow. It's just to the left of that staircase. It is a metal. So as soon as we see that metal, we should be thinking ionic compound, not covalent. All right, K2S. Potassium is right here. That is a metal. So this is not covalent, that's ionic. LiBr, we have Li, which is right here. That is also a metal. So that is also ionic. H2O. Hydrogen's right here. It's the one nonmetal on the left side of the staircase. So this is a covalent compound. Then we have FeCl2. That's right here, iron. And iron is a metal. So this is an ionic compound. Next, I have SCl2. That's sulfur and chlorine. These two are both nonmetals. So I'm going to circle this one. Last one, CH4. I kind of hid that one there. But we've got carbon and we have hydrogen. So both of those are nonmetals. So this is also a covalent compound. Okay, so here's the naming part of this. What you're going to do is name the first element. The first element keeps its element name. And we're going to add prefixes, and that's going to be the major difference between naming ionic compounds and naming covalent compounds. Covalent compounds or molecular compounds require that you use prefixes. Okay, the first element is going to get a prefix if there is more than one atom. You'll see some examples that'll make this clear. But you never ever use the prefix mono, which is for one, on the first element. We're going to name the second element, and just like before, when we were naming ionic compounds, the root of the second element changes its name ending to IDE. And this one will always get a prefix. So it'll get the prefix mono for 1 or any other number of that particular element that we're dealing with. Here are the prefixes. It's very important that you know these prefixes, that you have these memorized. Let's go through them. 1 is mono, 2 di, 3 tri, 4 tetra. Most of you know these, at least these first 4. I know 4 from tetra, okay? And then you've got 5, which is penta, like the pentagon has 5 sides. Hexa and hepta often get confused. I'd like to memorize them or remember them by saying hexa has an X in it, so does the word 6. So since both have an X, I can remember that hexa is for 6 and hepta must be for 7. You should know octa because we have been using that word octet rule over and over again to refer to 8 valence electrons. All right, then you have nona for 9 and deca for 10. The most common use of deca, decade, which means 10 years. You don't often see too many on this side, but you will see a lot over here. Okay, so we're going to do some examples. And I'm going to keep these prefixes in mind. First one, we have phosphorus and sulfur. So our first step is to write down the first element. It doesn't change its name. We give it a prefix if we have more than one of them. And so we have 4. And so we need a prefix for 4, which is tetra. So this is going to be tetraphosphorus. Then we have sulfur. And I changed its name ending from sulfur to sulfide. These are always going to end in "ide." So the second element always changes its name ending. All right, and then we need to say how many of these sulfurs we have. We have 8, and the prefix for that is octa. So this would be tetraphosphorus octasulfide. All right, next one, we have nitrogen. I only have 1 nitrogen, so I'm just going to name it nitrogen. Remember that the first element, you don't say how many there are if it's 1. If it's 1, you don't write mono nitrogen. That just doesn't exist. You leave off the mono for the first element. All right, and then we need oxygen. So that's going to change to oxide. We need to put the prefix on oxygen. There's 1 oxygen, so that would be mono. We don't say nitrogen monoxide. It just kind of is difficult to say. What we end up doing is we drop the O in the prefix and we just say nitrogen monoxide. You've probably have heard of carbon monoxide before because of carbon monoxide poisoning, but notice it isn't monoxide. We drop the O in the prefix and it says that, and it says if the root name begins with an O and the last vowel of the prefix is an A or an O, drop the vowel, the final vowel from the prefix. So if I'm dealing with mono, drop the O, right? I'm looking for this di, we wouldn't drop that. It's not an A or an O. We have tetra. Tetra would drop the A, so it would be tetroxide. Penta would drop the A, so it would be pentoxide, and then so on. So anything that ends in an A or an O, we would drop in front of oxygen. All right, next one. So we've got 4 nitrogens, so tetra nitrogen, and we have 10 oxygens. So prefix for 10 is deca. We drop the A, so this is tetranitrogen decoxide. And this is a little joke. Hopefully you don't have this as your grades. All right. Your turn to name those. And for this one, you're going to write the formula based on the name. So based on the number, look at the prefixes. All right. We're going to go through some diatomic elements. And so what these are, and I've kind of mentioned them before, these are 7 diatomic elements that exist in nature in pairs. That's just how they come. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. It's so, like, because of their closeness to each other and how many electrons they need, they just bond before they bond with anything else. Okay, so you have to memorize these 7. And there's 2 ways I'd like to do this. One is I like to remember the name Brinkelhoff, and I think of a professor named Brinkelhoff. So Dr. Brinkelhoff has 7 diatomic elements. Or if remembering Brinkelhoff or figuring out which ones are involved in that name Brinkelhoff can be a little bit tricky. So another way to do that is, if you notice, the elements involved are hydrogen over here, this one. And then they start at atomic number 7, nitrogen over here, and they form a 7. So nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So 2 ways to memorize that one, but you do need to remember. The reason for that is when we name them, we treat them a little differently. Okay, so when these elements are in their diatomic form, meaning they are not combined with any other elements, we simply name them by the name of the element. So if we're looking at N2, we just call it nitrogen. And you know this. If I were to ask you what's the formula for oxygen, normally before you walked in here, before we even looked at the periodic table, you'd probably just say O2, right? We breathe in oxygen as O2. So that's how it comes. So here we go. Here's a list. F2, we just call fluorine by its element name. Cl2, just chlorine by its element name. Okay. In order to do that, though, they have to be not combined with any other element, so that just by themselves. All right. Here's a little joke. Let's read through this. Ban dihydrogen monoxide. So here's the reason why we would want to ban this. It is a colorless and odorless substance. If you inhale too much of it, it could be fatal. If you're exposed to it in its solid form, it'll cause severe tissue damage. And symptoms of dihydrogen monoxide ingestion can include excessive sweating and urination and possibly a bloated feeling, nausea, vomiting, and body electrolyte imbalance. Have you figured out what dihydrogen monoxide is yet? Let's write the formula. Dihydrogen, so 1, 2 hydrogens. Monoxide, so 1 oxygen. You don't know that as dihydrogen monoxide, right? We know this as water. Which brings me to my next point. Some things just have common names. Instead of naming them by the naming system that I've just outlined for you with all of the prefixes, we name them by what we would normally call them, their common name. So you don't use the naming rules. Here's the 3. There's a few out there, but there's 3 that I want you to know. H2O, water. Don't call it dihydrogen monoxide. NH3 you may not know, but this is ammonia. Okay, it is such a common substance that we just call it by its name, ammonia. So this one you're definitely going to have to memorize. Another one, O3. So O2 is oxygen. If you took earth science, you know that O3 is way up in the upper atmosphere in the stratosphere. It is ozone, part of the ozone layer. So when you name those, just name them by those names. Okay, you're going to take a minute and name those. Watch out for common names. All right, I have a final note for you. Ionic compounds, remember, are different than covalent compounds, which means that the naming system, the naming rules for ionic compounds are different than covalent compounds. For example, okay, if I were looking at this formula right here, K2O, this is potassium with oxygen. I know that this is ionic because it starts with a metal. And so if I were to name this, I would just call it potassium oxide. Notice I did not throw any prefixes on it. Why? Because prefix naming system is reserved for covalent compounds. All right, that is it. Hopefully you got all of that.